So let me get started. And first of all, thank you for the invitation. My name is Kou Murayama from the University of Tübingen. When I first got the invitation from Consciousness Club, I was wondering why, because I didn't do any study about consciousness. And I tried to connect my presentation with consciousness, but I just simply gave up. So today I just decided to present what I have. And my background is basically education and psychology, but recently I have been interested in curiosity or how people sustain motivation without extrinsic rewards. And so this is the topic that I'm going to talk about today, a reward learning framework of knowledge acquisition. So the talk is about interest and curiosity. Interest constitutes an integral aspect of human functioning and supports an enormous variety of human behaviors, ranging from early learning in children to scientific discovery. One remarkable feature of curiosity or interest is that it motivates people in the absence of explicit extrinsic incentives such as money, prize, and social recognition. For example, think about Albert Einstein. He made an enormous achievement in science. And of course, his motivation to study physics may be partly explained by the fact that he's motivated to gain the extrinsic rewards, but it's quite implausible that his motivation is completely explained by the extrinsic rewards. He was able to sustain his engagement without relying on extrinsic incentives only. I've been wondering why people can sustain our motivation without extrinsic incentives like this. When I looked into the literature in psychology, I found that many studies show that interest is associated with many real-life outcomes. Basically, if you are interested, you would be better off. And there are also many studies showing antecedents of interest. However, when I did the literature review, precise psychological mechanisms underlying interest was still underdeveloped. By looking at the literature, I found two things that might have prevented the development of the literature. The first one is a contradictory meta-theories of interest. That is, in psychology and in neuroscience and modeling, there are two different ways of seeing interest. In psychology, interest is something special, which is qualitatively different from the motivation-driven extrinsic incentives. This is based on empirical finding. More specifically, many studies show that interest or intrinsic motivation and extrinsic motivation are associated with different outcomes. One particular example is Undermining Effect, which I'm going to talk about a little bit later. And some people even argue that these two things are completely competitive. On the other hand, in the field of neuroscience modeling, interest is treated as little different from extrinsic incentives. This is also supported by empirical evidence. More specifically, quite a few neuroscience studies show that interest and extrinsic motivation activate a common brain area, more specifically the neural network in the brain. Another obstacle in the field is that there are interestingly different research traditions on the similar topic. There's a research on curiosity in the field of cognitive science, neuroscience, or modeling. And in these fields, empirical research tends to focus on short-term information-seeking search behavior in simplified settings. And quantitative theories are predominant. So there are many quantitative theories about how we can describe, we can model information-seeking behavior. But interestingly, there's another research tradition called interest research in social or educational psychology. Here, empirical research tends to focus on long-term development with real-life materials using education materials and so on. And there are also theories about interest there, and they are all qualitative and they are relatively diverse. There's yet another line of research called trait curiosity or trait interest research. Here, empirical research tends to focus on individual differences with survey questions. And theories are mainly concerned with typology of individual differences. Importantly, Although they are actually studying very similar things, obviously curiosity and interest are similar things, but there have been little communication between the different traditions. Given these issues, the purpose of this presentation is to present a broad and preliminary conceptual framework, not a theory, to understand interest and curiosity in an integrative manner. So the biggest picture is to integrate two seemingly contradictory meta-theories of interest and to link different research traditions of interest and curiosity. The framework that I'm going to put forth is called Reward Learning Framework of Knowledge Acquisition. The basic idea is simple, and this is not a new framework, but I actually try to integrate different literature using this framework. The basic idea is simple. Interest or curiosity involves internally generated rewarding processes in knowledge acquisition when extrinsic incentives are not available. Extrinsic incentives play an important role to shape our behavior, but extrinsic incentives are not always available, especially in higher order activities, such as reasoning and creativity. In the evolutionary process, humans and other higher organisms acquire the ability to self-generate rewards from knowledge acquisition to sustain, boost, and segregate their behavior when extrinsic incentives are not available. And this is what we naively call interest or curiosity. Importantly, this framework tries to explain two contradictory perspectives about interest and extrinsic motivation. On the other hand, this framework indicates that interest and curiosity can be portrayed as reward learning of knowledge acquisition. Hence, there's a similarity between interest and extrinsic motivation or incentives. But at the same time, reward learning of knowledge acquisition involves unique features that make interest distinct from extrinsic incentives, which I'm going to visit later. So this framework uses a common reward learning framework by which we can explain the commonality between extrinsic motivation and curiosity-based segregation. But at the same time, the framework also explains how segregation based on interest is different from segregation based on extrinsic incentives. Let me go through each topic one by one. The first topic is interest and curiosity can be portrayed as reward learning of knowledge acquisition. It's not that a new idea, but let me just explain it. This is a standard reinforcement learning model. There's a conditional stimuli and an agent makes an action. Then the agent may be able to get an extrinsic reward, such as food. Then there's a rewarding experiment which reinforces the action. As a result, when the same conditional stimuli is presented, the agent is more likely to take that action again. This is something you are very familiar with. And in the neuroscientific literature, there are many studies showing that this process is related to the reward network in the brain. We can think about a parallel in the information-seeking behavior. That is, when there's a knowledge gap, then people may want to do information-seeking behavior, and as a result, the agent can acquire knowledge. Importantly, this knowledge acquisition itself could serve as a reward. That is, the agent may have a rewarding experience, and as a result, this information-seeking behavior is reinforced. And as a result, when the knowledge gap is made salient again, then the agent is more likely to take the information-seeking behavior again. In other words, knowledge acquisition and extrinsic incentives work in a similar way to regulate behavior, and that's why there are similarities between them. There are indeed many studies nowadays that indicated the similarity between them. This is the first study in my mind that examined the neural correlates of curiosity. So this is a seminal paper about curiosity and neural correlates. And they found that they used trivia questions to induce curiosity for participants and found that the neural network in the brain is related to, especially the stratum was related to the curiosity induced by the trivia questions. It's not only about trivia question. There are many studies using different tasks that investigated the neural correlates of curiosity, and they consistently found the involvement of the reward network, or more specifically, the striatum in the brain. Nowadays, there are many modelings about information-seeking behavior curiosity. If you are interested, I think many of you are actually familiar with this topic, but if you are interested, this book is a good first step to understand the development of this kind of things. If we can suppose that interest and segregation based on extrinsic rewards are both based on reward learning, we can make an interesting prediction. Let me explain this. In the standard reward learning model, it is supposed that people can actually optimize the behavior by maximizing the reward. However, in reality, it's not that simple. For example, in some cases, the rewarding experience induced by extrinsic reward are so strong that people may take irrational impulsive behavior. One good example is drug addiction. Everyone knows that it's not a good idea to take drugs. However, in some cases, the rewarding experience due to the drug is so strong that, in other words, incentive salience of the rewarding experience is so strong that people cannot control their own behavior. If curiosity works in a similar manner as extrinsic rewards, then we can make a similar prediction. That is, after the knowledge acquisition, it's possible that rewarding experience is so strong that people may take an irrational, impulsive behavior. Actually, it's not difficult to find such an example. For example, you can think about the Greek mythology, such as Pandora and so on. I will take the example of Orpheus. In this Greek mythology, Eurydice and Orpheus are a husband and a wife, but Eurydice passed away. Orpheus got devastated such that he decided to go to the underground to negotiate with Hades. And remarkably, Orpheus successfully negotiated with Hades and got the Eurydice back. However, on his way back to the overground, he was told not to look back. Now you should be familiar with the story. He knew that there might be something wrong happen if he looks back. However, he succumbed to the temptation to look back, and he actually looked back, and as a result, he lost Eurydice. This is a nice example of how curiosity can push people toward a risky behavior. I wanted to replicate this idea inside a fMRI scanner, which is a little bit challenging because, as you may know, inside the fMRI scanner, things are quite dark and noisy, so it's quite difficult to induce curiosity or interest. We discussed a lot, and we finally ended up with using a very peculiar stimuli, which is magic trick. In this experiment, participants will watch the video clips of magic tricks, and we invited actually magicians to the lab and videotaped them. Let me show you some examples. I hope you can watch it without any disruption. I hope this triggered your curiosity a little bit, and I hope you can see it without any problem. He was a champion of a world magic competition. And let me show you another one. He is a social psychologist and actually one of the co-authors of the paper. Oops, sorry. I hope this also triggered your interest. I didn't edit the video, so this is a real magic trick. We got more than 100 this sort of magic tricks, and we actually got solutions to these magic tricks as well. It turned out that if we pay well, magicians are sometimes happy to show the solution of the magic tricks. So participants are presented with these magic tricks in the fMRI scanner. Then participants are presented with a lottery. And with a lottery, participants have to make a decision of whether they would like to take the lottery or not. If they decide to take the lottery, they have the possibility to see the solution of the magic trick that they just saw. On the other hand, if they take the lottery and they lose, then they would receive an electric shock after the experiment. So this is a risky decision because there's a possibility that you can satisfy your curiosity by taking the lottery, but at the same time, by taking the lottery, you may get an electric shock. If the participants decided not to take the lottery, then they don't need to receive an electric shock, but at the same time, they would lose the possibility of seeing the solution of the magic tricks. We also had a food condition in which food pictures are presented, and the structure is the same. So participants are presented with food pictures and then decide whether they want to take the lottery or not. If they take the lottery and they win, they can eat the food after the experiment, but there's a possibility that they would receive an electric shock instead. If they decide not to take the lottery, then they don't need to receive an electric shock, but at the same time, they cannot eat the food after the experiment. We basically found that people are actually very happy to take the risk of receiving electric shock to satisfy their curiosity or hunger, especially when the food was attractive or especially when the magic tricks was quite curious. But what are the neural correlates? What we found is that neural network, especially the both part of the striatum, was related to the decision of accepting electric shocks for both magic tricks and food, indicating that the decision to take the risk to satisfy curiosity has a similar brain mechanisms as the decision to take a risk to satisfy the hunger. So this is another evidence indicating that motivation by curiosity and motivation by food may be supported by the similar brain mechanism. Another postdoc of mine conducted an interesting behavior experiment to see the power of curiosity in a different setting, which we called counterfactual curiosity. In this experiment, we used a modified balloon analog task, which you may be familiar with. In this experiment, participants had to make a decision before the task about how many pumps they would like to make for the balloon. The more pumps they made, the more money they can get. However, if they pump the balloon too much, then there's a possibility that the balloon would burst and they cannot get any rewards. This is a typical risky decision-making task. But we added a tweak to this experiment. After seeing the outcome of the experiment, participants are asked to make a decision of whether they want to see the limit or not. That is, they have opportunity to see the limit of the previous trial. By limit, I mean the limit of the balloon. And importantly, participants had to pay a cost to see the limit. For example, in some experiments, they had to pay money. In some other experiments, they had to make an effort. In some other experiments, they had to wait. Anyway, participants, we wanted to see whether participants are happy to pay cost to see the limit of the balloon in the previous trial. Importantly, for each trial, the limits were determined at random. Therefore, seeing the limit would not affect any performance for the next trials and after. Nevertheless, in more than 40% of the trials, they opted to see the limit, indicating that participants are quite curious about the counterfactual information. What is more interesting is that we also assess their feelings about seeing the limit. And we found that after seeing the limit, they got more negative because by seeing the limit, they felt that, I could have pumped more. So they regretted more. In other words, people are so curious that they even incur cost to experience regret. This is another demonstration of how curiosity can push people into a risky behavior or irrational behavior. So I have presented some evidence indicating the commonality between curiosity and extrinsic incentives, but they are not the same thing. Your learning of knowledge acquisition involves unique features that make interest quite distinct from extrinsic rewards. I'm going to go through one of the 4 points one by one. Again, this is a standard reinforcement learning model by extrinsic incentives. One critical thing about this reinforcement learning is that after participants receive the extrinsic reward, the agent usually consumes the reward. In other words, you need a constant supply of extrinsic rewards to sustain this segregation. What about the segregation based on intrinsic incentives or knowledge acquisition? The critical difference is that the reward here is a knowledge acquisition. And knowledge is quite different from extrinsic incentives because once knowledge is acquired, it's actually integrated into one's self-knowledge or knowledge base. Why does that make a difference? Once you get the knowledge, then your knowledge would be actually expanded. And normally this would produce more questions about the topic that you are learning, which may prompt further knowledge gap for participants or agents. And as a result, the agent is more likely to take information seeking behavior. For example, think about learning statistics. When you learn statistics of, for example, multi-regression analysis, you may feel you are done, but in many cases, you may not feel you are done. You may have more questions about the regression analysis you just learned. Is that different from correlation analysis? Can multi-regression analysis can tell causality? This is the kind of question that people spontaneously produce after learning new facts. Another important thing that once you acquire knowledge, you tend to value that new thing that you are going to learn. Again, think about the statistics. When you study psychology in the first place, people hate statistics because many people don't expect to study statistics when they first study psychology. However, as they understand how psychology works in academia, they tend to value the knowledge of statistics more, and as a result, the value of statistical knowledge would be increased. In other words, rewarding value of knowledge may change as a function of accumulative knowledge. Another important thing is that knowledge can be a basis of understanding new information. In the reinforcement learning framework, it is sometimes important to think about skills to understand the stimuli from the external world. And once you acquire knowledge, you can actually improve your skills. And this may prompt further information seeking behavior. What does that mean? This means that agents can create a positive feedback loop that self-boosts rewarding experience over time. And once you establish the process, you can increasingly self-generate the rewarding feeling. This way, the agent can sustain commitment to the knowledge acquisition process without extrinsic rewards. In other words, in a sense, interest-based segregation is more sustainable than segregation based on extrinsic incentives. It may be counterintuitive for some of you that the more knowledge you acquired, the more questions you would produce. This means that the more knowledge you acquire, the less you feel you know. But this can be understood in this way. This is, think about the situation in which you are learning new things. And at the beginning, you don't have much knowledge about the topic. So you have a very small knowledge base here. Can you see my clicker, by the way?
Yes.
I hope you, okay, thank you. When you have little knowledge, actually you have little things that would be associated with your current knowledge because you have no knowledge about the topic. But once you build up your knowledge, then you have more potential knowledge that can be connected to your existing knowledge. In other words, you have a potential of having more questions about the topic. Of course, the situation would change when you have a kind of saturated knowledge about the topic. But in reality, the knowledge is quite complex, and it's quite unlikely that you get to this stage. So in reality, in most cases, the more knowledge you acquire, the more questions you have. And as a result, you are more curious about the topic. I actually did a kind of simulations to demonstrate that using different knowledge network, showing that the knowledge gap can increase as you acquire new knowledge. From this idea, a potential prediction is that our first few doses of interest could make a big long-term difference due to the self-boosting effect. In other words, initial differences in interest would become larger over time, creating a bigger gap between those who are initially interested and those who are not, which can be called a snowball effect or Matthew effect. I came up with this idea relatively recently, so I don't have much data to demonstrate this. But when I looked at my publication, there are some papers that actually indirectly prove this point. For example, this is one study that I conducted in Germany. This is a 5-year longitudinal study of math achievement in German schools. And we examined the students' change of math achievement over years. Here, the solid line represents students with high initial intrinsic motivation for mathematics, and the dashed line represents students with low initial intrinsic motivation for mathematics. As you can see, at the beginning, there's no difference between these two groups of students, but what is interesting is that the difference gets larger as time progresses, indicating that interest for mathematics has a cumulative effect on learning. I'm going to skip this slide because it's a little bit complicated to explain, but I also found a similar thing using older and younger adults with trivia questions. This is the analysis of the data that I published long ago. In this study, we simply asked participants' interest about the topic of psychology for every week in a psychology class. What we found is that when we examine the students with high initial interest and contrast these students with low initial interest, actually the interest between these two types of students get larger as the course progresses, indicating a sort of snowball effect again. This effect is a little bit remarkable because statistically speaking, this gap should decrease over time because of the regression to the mean effect. My first PhD student, Greater, actually came up with a nice design that could examine this idea. In this experiment, participants are presented with pieces of information about lesser known countries such as East Timor. And participants can see each piece of information one by one for each of the country. And importantly, after seeing the information, participants could indicate their interest in the country. This way, we can systematically examine how interest increases, decreases as a function of knowledge acquisition. The results are quite complicated, but let me show you the most representative findings. Basically, generally speaking, the more participants acquired knowledge, the more interest participants acquired. So there's an increasing trend of interest as people acquire knowledge. However, when you focus on the country with high initial interest and countries with low initial interest separately, the picture is that there's a difference between these two countries at the beginning, but this difference gets larger as people acquire more knowledge, supporting the idea of snowball effect. So I have discussed the potential snowball effect of interest over time. And this actually speaks to the next property of interest, which is selectivity. So I talked about interest snowball effect. One implication of this interest snowball effect is that it could address one big mystery of interest, that is, large individual differences. We know that there are large individual differences of interest. Some like mathematics, but some other people like arts. Some other people like dance. We also did a kind of quantification of individual differences using trivia creation, magic tricks, and so on, and we consistently find that the individual differences are huge. It's not that remarkable because we already know that individual differences are large, but no one actually asked or tried to address the answer of why, because it's quite difficult to empirically address it. And I wouldn't empirically address it, but I'm going to give you my speculation. I think that snowball effect may serve as an inherent mechanism that could selectively bolster particular areas of interest. This is because with the snowball effect, initial small differences would result in large differences over time. By applying this idea, we can actually speculate that large individual differences may be a consequence of interest snowball effect. That is, we may have very small differences of preference or internal rewards for specific topics, but as a result of the snowball effect, these differences get larger over the development, and as a result, nowadays, as an adult, we have various interests between various people. This tendency may be further strengthened by our tendency to self-reinforcing preference. People have a tendency to justify their own decisions, and this has been demonstrated by many social psychology literature. And I also think that this tendency further strengthens the self-boosting effect of interest because, for example, I like statistics a lot. I can tell why I came to like statistics for 2 hours. And this may be partly explained by my tendency to justify of my preference for statistics, because humans are quite good at making such justifications, even if that's not true. So implication is that people's large individual differences do not exist as a beginning, and minor differences in the initial conditions, which may be determined by random factors, may make a big difference in interest development. So we now have many different interests between people, and we may be able to explain why we got interested in a certain topic. For example, I can explain why I got interested in the topic of psychology, but this big interest may be initially determined by a random factor in the environment. This could also explain an emergence of trait interest or curiosity. As indicated earlier, there's a field called a trait curiosity or trait interest. And indeed, there are so many traits in the field about the curiosity and interest. Many people propose different dimensions of interest and curiosity, which is confusing. And there are many similar traits related to curiosity, like novelty seeking, sensation seeking, need for cognition, and so on. And even in big five personality traits, there are traits related to curiosity and interest. It's beyond the scope of this talk to discuss which dimension is most fundamental. But one important question is why there are so many personality dimensions that are related to curiosity or interest. The interest snowball effect can effectively explain this kind of things, because we can say that due to the self-boosting process of reward learning in knowledge acquisition, interest and curiosity have an inherent property to manifest as a major personality dimension, because it can self-boost itself. This could provide a kind of mechanisms on how state curiosity interest transforms to trait curiosity interest. Let me talk about the third topic, which is vulnerability. So far, I have discussed that both extrinsic rewards and intrinsic reward would be processed in the common reward learning system, but intrinsic rewards are quite unique in that it has a kind of self-boosting property. But what if both extrinsic rewards and intrinsic rewards are present? Evolutionarily speaking, intrinsic rewards are relatively new mechanism, and extrinsic rewards are relatively old mechanism, and extrinsic rewards are more tangible and salient On the other hand, intrinsic rewards are abstract. As a result, when both of them are present, we can actually suppose that extrinsic rewards, process of extrinsic rewards would be prioritized, and processing of intrinsic rewards may be suppressed. You can actually find these kind of examples in the literature of social psychology. For example, when you think about Festing and Carl Smith's classic work on insufficient justification, you can see this example. In this experiment, participants worked on very boring tasks, like turning pegs in a pegboard for an hour. And there were two conditions in this experiment. Small reward condition, in which participants received $1 for participation, and large reward group, in which participants received $20 for participation. They also assessed self-reported interest for the task. Counterintuitively, the experiment showed that participants in the small reward condition showed higher interest for the task in comparison to the participants in the large reward group. This can be explained by the mechanisms that I explained earlier. That is, participants actually created interest when monetary rewards are not salient. Participants were able to create interest when there's no extrinsic incentives because there's a self-boosting effect. But once reward is presented, then extrinsic reward is processed in a prioritized manner, and as a result, the generation of self-reward would be suppressed. We actually did an experimental study that investigated the neural correlates of this effect, but I'm going to skip this study. And another example, or more direct example, is undermining effect, which was actually touched on the introduction. Undermining effect is a phenomenon in which provision of performance-based extrinsic incentives decreases intrinsic motivation for a task. This is actually compatible with the current idea. That is, if extrinsic incentives are available, the system does not effectively process internal rewards. We did an experimental experiment in which we examined the neural correlates with the undermining effect. In this experiment, participants worked on a game-like task called stopwatch task, but importantly, there were two groups, reward group and the control group, and the reward group participants received performance-based payment for this game-like task. After this task inside the scanner, participants received a reward. Then participants are asked to wait for the next session. From the participants' perspective, this is just a waiting period. And indeed, participants could do whatever they wanted. Participants could read a magazine or could even take a nap during this waiting period. But importantly, there's a computer in the waiting room by which participants could play the stopwatch task. Again, from the participants' perspective, this is a waiting period. So they were not forced to do the task. And if they played with the task with the computer, then we could actually regard this behavior as a manifestation of intrinsic motivation or interest. To examine the brain activity associated with undermining effect, participants were put into the scanner again after this waiting period. And in this second session, neither group of participants received performance-based payment. This is the behavioral results. As expected or consistent with the undermining effect literature, participants who received a reward after the first session actually played with the task less frequently than the participants in the control group during the waiting period. What are the brain results? In the first session, both group of participants showed the activation in the striatum. This makes sense because they got excited to play with the task. This activation was actually higher in the reward group, which also makes sense because participants got more excited because they were able to get more money by succeeding in the task. In the second session, neither group of participants received performance-based payment. And participants in the control group sustained the activation in the striatum. This makes sense because they essentially did the same thing in the first and the second session. So they still enjoy the task. But what was interesting that the activation was completely eliminated in the reward group, indicating that they were never able to generate intrinsic rewards out of the task. This is a little bit puzzling. This might be a little bit puzzling from the pure reward learning perspective. But when you think about the weights given to the intrinsic rewards and extrinsic rewards in computation of reward learning, this actually makes sense. In the reward group, there was a kind of prior, so the weight for the extrinsic reward would be increased. And as a result, the generation of intrinsic reward is suppressed. From this perspective, we can actually explain the undermining effect within the framework of reward learning. The last point I want to make is the underappreciation, which is related to metacognition. Again, this is a standard reinforced learning model. And one implicit assumption of this reward learning model to work effectively is that participants have a kind of accurate metacognition about the expected reward value that they can obtain after making action. In other words, participants should constantly make a metacognitive judgment about the expected reward value. And this has to be precise to make the behavior optimal. And the previous studies indicated that there were some biases, but basically participant judgment about the expected reward value is accurate by and large. What about information-seeking behavior or segregation based on curiosity? Again, the important assumption of this model is that we need to make an accurate judgment about the rewarding value of knowledge. However, knowledge is very abstract. It's quite difficult to know how much rewarding experience you can get when you acquire the knowledge beforehand. In addition, there are so many hidden processes going on, like the new question generation and so on. And as a result, we can easily imagine that this is not an easy task. Indeed, with this in mind, we can actually make a prediction that people could underestimate the rewarding value of new knowledge because there are so many hidden processes that would boost the value of information. To test this idea, we actually launched a kind of meta-motivation project, which we called. In this meta-motivation project, participants worked on a task. And in some of the projects, participants worked on very boring tasks, such as flank a task for 30 minutes, delete is from 10 pages of text, and so on. Actually, participants read my papers in English, so participants are exposed to my academic papers and asked to delete is from my academic papers. After this task, participants are asked to rate or indicate their motivation. We also assess motivation behaviorally as well. This is a standard motivation task, but we added a tweak. That is, before working on the task, we also ask participants to make a prediction about the motivation after this 20 or 30 minutes. And this way, we can compare the predicted motivation and actual motivation and examine the accuracy of metacognition. We use various boring tasks, and what we consistently found is that people actually enjoy the boring tasks way more than they expect. So people tend to think that, oh, task is going to be super boring, but actually their actual enjoyment was more than they actually expected before the task. I must say that people didn't enjoy the task a lot. Their rating is mediocre. However, still the expectation was worse than the actual enjoyment. In some of the experiments, we also gave rewards to participants to do the task. What happened? Here, we found that consistently that participants actually overestimate the effective rewards on motivation. That is, when they were promised rewards, they tend to think that they would enjoy the task, but actually the enjoyment wouldn't be influenced by the presence of the reward. Of course, it's not easy to define boring tasks, so we actually conducted an experiment, an extreme experiment. In this experiment, participants were just asked to wait in a dark, silent room for 20 minutes and do nothing. This is a kind of replication of the sensory deprivation experiment conducted in 1950s and 1960s in psychology. participants actually put on earphone. Therefore, participants couldn't listen to any sound from the external world. Participants couldn't see anything because it's in a dark experimental room to the perceptual experiment. And participants were removed from the, we removed electric devices from the participants. So participants, for example, couldn't check any internet or mobile phones and so on. Participants are just asked to wait in this dark room for 20 minutes. After the 20 minutes, we asked participants whether they were happy with the task or they enjoyed the task or they got motivated with the task or not. Unlike the previous experiments, we also asked participants to make a prediction about their enjoyment and motivation before the task and compare them. It turned out that this is one of the most robust findings I got in my career. If you want to replicate, please, because it's quite easy experiment to conduct. You need nothing. You just need a room and you can just turn off the light, then you can do this. What we found is that people enjoy just waiting more than expected. And the results are very consistent and the effect size quite large. So what are the implications? When we make an information-seeking behavior, it's based on the accurate assessment of the rewarding value of the information. However, if this is inaccurate, as I indicated in my empirical studies, then our decision-making should be maladaptive. We try to show this in an experiment that we conducted. In this experiment, this is a follow-up experiment of the Darkroom experiment that I explained earlier. In this experiment, before the task, participants are provided with a choice from two options. In one option, participants would do a task in which they just sit in a dark room and think. So this is the same situation with the previous experiment. In the other option, participants actually could play with internet. And we asked participants which option they want to take. Not surprisingly, most of the participants wanted to play with the internet. However, when we assessed their enjoyment before and after the task, what we found is that participants selected internet because they thought that that's much more interesting than waiting task. However, their actual enjoyment was not that different after the task, indicating that participants actually missed a lot of opportunities to have an enjoyable thinking period by overestimating the enjoyment of internet. This inaccurate meta motivation has some implications. So we show that inaccurate meta motivation leads to suboptimal decision making. This could explain, for example, this could also explain our over reliance on rewards for self-motivation or motivating others. For example, I was in a university in the United Kingdom, and the university imposed many grant targets on me, which I really hated. I was wondering why, because I would do research even without being imposed a grant target. But they actually impose a target out of the goodwill or good intention. They genuinely feel that giving a target would motivate people. This is how the inaccuracy meta motivation plays a role in our decision-making process. And if policymakers, stakeholders have that kind of belief, which should be common based on my findings, then we tend to over-rely extrinsic incentives to motivate other people's behavior or motivate yourself. So in summary, I presented the kind of framework that examined, that explained both the similarities and differences of curiosity and extrinsic incentives. So it could accommodate two opposing meta-theoretical perspectives of interest and curiosity. And this perspective could also integrate three different research traditions on curiosity, that is research on curiosity, research on interest, and research on trait curiosity and interest. Research on curiosity tends to focus on the short-term information-seeking behavior, which can be represented by the inner circle of the presented figure. On the other hand, research on interest which focuses on the long-term development of learning or information-seeking behavior, which tends to be represented by the outer circle of the figure that I presented. And research on trait curiosity and interest is more about the generalization of this information-seeking behavior after the repeated cycle of this process. So the framework provides an integrated scheme to link these different research traditions. I'm going to finish quite soon, but before just closing, I just touch on a little bit future directions. In this presentation, I focused on knowledge acquisition as a source of intrinsic rewards, but I think there are other sources of intrinsic rewards, such as effort and social reinforcement learning. For example, I'm now doing projects about the value of effort. In the literature of economics or decision-making behavior, the norm is that effort is aversive, people avoid effort. But sometimes people genuinely seek effort. Think about question, why do you want to climb Mount Everest? One famous answer made by this person is because it's there. And of course, it's possible that he was motivated by the to get some social reputation from the people. But at the same time, it's also possible that he was genuinely motivated to overcome challenge. We have been doing several studies that investigated why people choose a difficult task. And some other research groups focused on learning progress to understand why people choose a difficult task. But in our projects, we try to eliminate the possibility of learning progress and examine the people's choice of difficult task in the situation where there's no learning progress. And I wouldn't explain these experiments because it's a little bit complicated, but if you are interested, I can explain later. But basically what we found is that when reward is provided, people tend to prefer easy tasks when there's no learning progress. But if there's no reward at all for the task, then people increase the preference for difficult tasks, even if there's no learning progress in the task. And this is also associated with activation in the neural network in the brain. Another project is motivation contagion project. When we think about why you come to learn or why you come to like, for example, mathematics or science or some other subjects, one common answer from students is that I liked it because my friends liked it. And I feel that this kind of social reinforcement learning component plays an important role to build up internal rewarding structure in people's mind. So I have been now interested in how people's motivation is influenced by their friends' motivation. To do this, we actually need to assess people's real-life social network and examine how this real-life social network influences people's motivation over time. For that purpose, we assess student social network in a local school, and then we scan these students and we examine how the network of the brain and motivation would become similar or dissimilar over time through the social network. On the one hand, we found the promising evidence for the behavior assessment of motivation. That is, if there's a tendency that two friends tend to like the same subject over time, but at the same time, in terms of brain activation, we haven't found a promising evidence about the similarity between friends. That I'm gonna skip this slide. The last thing that I would like to just discuss is the theoretical state of motivation. My lab is called Motivation Science Lab, and many people assume that I'm an expert on motivation, and many people ask me a question, what is motivation? And I actually don't like the idea of motivation at all when we think about human functioning. When you look at the literature of motivation in psychology, you can find numerous different types of motivation, like intrinsic motivation, achievement goals, need for achievement, and so on. Lots of types of motivation in the literature. I'm not telling a lie. If you know the field of motivation, there's a kind of inflation motivation concepts like this. People can generate their own types of motivation to explain human behavior. I really didn't find this productive. Do we really need such concept of motivation to explain pattern of behavior? When we computationally model behavior, these concepts may not be necessary. That's my understanding of the concepts. And I even think that the concept of motivation might have hindered our understanding of mental processes. So think about this reward learning framework of knowledge acquisition. This framework can explain our curiosity, but there's no element of curiosity in this mental process. There's no word of curiosity in the process, but still we can explain the behavior which is normally attributed to curiosity by lay people. Some people explain this behavior using the term of need for competence. There are a kind of group of people who indicate that people have a fundamental motivation, competence, autonomy, and relatedness. I'm sympathetic about the idea, and I like the idea actually quite a lot, but at the same time, I feel that this need for competence, so to speak, may be just a kind of emergent phenomenon coming out of these basic psychological processes. Again, there's no need for competence represented in this schematic picture. So my point is that motivation is important to explain our behavior at a verbal level. But when we really want to understand why people are motivated that way, or why people are seen as motivated, actually we need to abandon the word motivation and try to explain the behavior without using it. I feel that this is a more productive way of moving forward the field. That's it. And I also have some postdoc positions and PhD positions. So if you have anyone, if you know anyone who may be interested in this type of topic, please get in touch with me. Thank you very much.